Hi there, this is session 25 of programming from the very basics using Python. In the previous session, I talked about more of the features of a set, and I also introduced you to a dictionary. I told you how you can construct a dictionary using three or maybe four different ways. So I'm just trying to go and recap because this session will focus more on the dictionary. We'll learn all about dictionaries in this series. So to construct a dictionary, I already told you, you can use a literal notation, which uses curly braces. You can have it in a single line if a dictionary is small, but you can actually nicely organize it in a multi-line format like you see here, where I open curly braces and you have the key colon value followed by comma, key colon value, and so on till the end. One of the things I told you about the keys of a dictionary are unique and they must be hashable. And I told you what hashability is. If you have skipped that, go back to the last two sessions when I talked about sets and hashability, right? So I told you the keys should be a hashable object. So in this case, I'm using a string. You can also use a number or any hashable object in this case, but strings are generally preferred for a dictionary. Now I've created a key which is a string, and the value can be anything. The values don't have any restrictions on a dictionary. It can be any valid Python object. You can have values that can be strings, can be list, can be another dictionary. It can also be functions or modules if you prefer. So any Python object which you can refer to can be a module. Can be a value, right? So this is how you can see one of the values is a string, the other one is a list, and you can see another one is just a number. It's an integer, and the last one is a boolean. You can have any arbitrary objects represented as values in a dictionary. So dictionary is very, very flexible, right? So you can represent a dictionary in the literal notation by using the curly braces, and I'm just printing weather here. But if you prefer, you can also use the constructor expression to construct a dictionary by using the dictionary constructor. If you remember, I told you that when you use a constructor expression, there are some restrictions, which I believe is anyway good because one of the restriction is it expects the key to be a string, which is based on an identifier naming convention, which means this must be a single word string. No special characters are allowed because you can see it looks like an identifier, not in quotes, right? So it must start with a letter or an underscore and contain alphanumeric characters and underscore. That's a rule here. And obviously can't have anything else. And the next restriction is all about duplicate keys. So when I'm constructing a dictionary using literal notation, you can always have duplicate keys with their corresponding values, which should be different. One of the key value pair will be retained. All the previous ones could be lost. The last key value pair, which of duplicate, will be retained. Whereas when you use a constructor expression, that will flag off as a syntax error. So these are things you should know about the restrictions of using the dictionary constructor to create a dictionary. But though with these restrictions, I would personally prefer creating a dictionary using the syntax. Just it's more convenient and it avoids ambiguities in most cases. Also, you mentioned that in the previous session. And you can also construct a dictionary by using a dictionary constructor with a 2-item tuple set or 2-element tuple sets, which I'm constructing using a zip construct, which is there here. So you can see keys happen to be maintained separately in a tuple. In this case, it can be a list or any iterable. It must be hashable, though. All the items must be hashable in here. And the values are likewise matching the keys. Using zip, you can create a zip object, which will create a 2-element tuple when you iterate over it, and you can construct a dictionary out of it. So all of these three forms work just fine. So based on your convenience, you can use any one of these. And the last form is obviously you can construct a dictionary using comprehension expressions. One of the simplest example I gave you is not to do with this example, but can't do with weather. It's all these are actual values, which I sort of wrote it, right? But then if all I want to maybe create a dictionary called squares, which represents squares of each number in a given range, I can say squares equal to x colon x into x for x in range of 10. This will create a dictionary of squares of the first 10 numbers starting from 0 to 9. So you can access the values based on keys and find out what the squares are. So I told you how you can create a dictionary using this technique. So the keys of a dictionary are hashable, they're unique. These are the properties of a set. But the only difference is that in Python 3.6 onwards, dictionaries by default are ordered in Python, which means that in what order you represent the key value pairs, either through comprehension expressions like here, or zip, or literally, the order is just maintained as is. Now, having said this, what are the different operations you can perform on dictionaries? Well, let me show you how to access items in a dictionary. First of all, I told you it's a collection. So let's check all the collection features. So to say an object is a collection, I told you it has to support three basic traits. One, they must have a length. So let's check for length here. I can say length of weather, which I created in the previous cell, by the way. There are four key value pairs in weather. So you can actually check it up. You can see this is the first key value pair, this is the second, the third, and the fourth. So it returns 4. This represents the length of a dictionary. You can also check for existence of a key in a dictionary by using the in operator. So people might call this the membership operator. I've seen that used in a couple of books and tutorials, but you can call it that. So you can just check for existence of, let's say, a key called raining in weather. This key exists. So I'm just going to print them all. And the last trait to verify that an object is a collection is obviously it must be iterable. So you can check for that by using the for loop. You just say for k in weather. I'm using the variable as k, but you can give it any name you want and just print k. It lets you iterate over the keys of the given dictionary. So these are the three traits to prove that this is obviously a collection. Once you create this dictionary, you can access items. You can check for existence of items using the in operator. We did that. You can modify the dictionary by various forms, various ways. So we'll discuss all of that coming down in further now. So first, I'll tell you about the dictionary called weather here. If at all I want to, let's say, access an item of a dictionary, basically the value, I need to know the key. So let's say I'll try weather of city. Returns the weather for the city where I'm residing it. I stay in Chennai, India. So it just says returns Chennai. And this is a subscript operator which I'm using, but what you pass here is a key. And the key should exist. If the key does not exist, it will raise an exception. So we try to check for weather of state, for example. It raises an exception called key error. So this is what happens when you try to access a key that is not existent in a dictionary. Now, sometimes you may want to handle this in a more safe manner. Basically, I want to look for existence of a key. If the key exists, I want to retrieve the value for it. Otherwise, I just want to ignore it or maybe set a default value. The way you can do that is you can use maybe a ternary expression. That could be a convenient way where I could just print weather of, I'll just use a variable called k, which I will set. I'll use key rather, okay? Weather of key. But now I'll just set key is equal to city. And I'll try weather of key. If key in weather is being a dictionary, so I'm checking whether the key by the variable name key is existent in a dictionary. And if it is there, return it. Else, I can just return either none to say that ignore it this way. If because the city exists in this dictionary called weather, it's going to evaluate this expression. But if I try something like state, this time it's not going to flag an error because I'm going to first check for existence of the key in the dictionary. If it is there, then this expression is evaluated. Otherwise, it's going to return none. But maybe you don't want to return none, you want to return something default. You can put whatever default value you want to return by modifying it. I can just say maybe key not found. So whatever expression you put in the else clause, that will be evaluated in case the key is not found. Now, this is an expression which handles non-existence of a key in a more graceful manner where you don't have to resort to writing try except blocks to handle exceptions. I still didn't talk about handling exceptions. I will cover that in the coming sessions, right? So for once I finish all these concepts up to functions, then I'll talk about the next level. Anyways, but this particular expression which I told you can be simplified. You don't have to write this expression when you need a situation like this, when you have a use case like this where you want to return a value for a given key if the key exists in a dictionary, or else you want to return something else, maybe a default value. Then you can instead use a method on the dictionary called get method. Just try this. Just say whether.get of key. Just try. Let's try key is equal to city, and you get Chennai. If not a try, key is equal to state this time, and then try whether.get of key. We know that state is not there in the dictionary. When I try this out, by default, it returns none. The REPL doesn't print it. If you use print function, you'll get the output printed as none, which you can actually verify when you call with print function here. You can see. So this is what happens if the key does not exist in a dictionary. But then maybe you want to return some default value for non-existent keys. In such cases, you can use a method which is dictionary.get of key, comma, you can specify what you want to return as a default. Maybe you can just return another arbitrary string mentioning key not, or you can say key not found. You could do that. So the get method is the convenient equivalent of this ternary if expression that you might want to wire up. You don't have to do this. You can rather use the get method instead. So it's a very convenient feature. So I told you how to access an item or a value from a dictionary once you know the key. But then sometimes you might want to update the dictionary. You want to change the contents of a dictionary. How do you do that? What are the kind of updates that you can perform? Let me just bring back the dictionary here. Let me just get a cell below. Let me just print weather. I think you will just see what weather is at this moment. This is what the dictionary looks like at this moment, right? Now I want to change the city from Chennai to some other city. Maybe I want to change it to, let's say, Bengaluru. So I can just do this. I can just type weather of city equals Bengaluru. We try to print weather now. The city has changed to Bengaluru. Yeah, obviously I'm not sure if Bengaluru will have a temperature at this level at this moment. It's generally a cooler place compared to Chennai, but we don't know that. These days, all cities are becoming hotter in India. All right, so we can see that you can always use dictionary of key equals any expression. There could be a value here. So it's going to change the value for an existing key. But you can use the same expression to also add a new key value pair into a dictionary. So for example, if at all I try this, if I try to type maybe weather of state equals Karnataka, which is the state where the city Bengaluru is. And I'll just do one thing. I want to keep the original weather to begin with so I can actually see the complete trails. So I'll just copy this version. Hang on a minute. Yep. Yeah, you can use the literal notation or the dictionary constructor. So it doesn't matter. So I'll use the dictionary constructor here. You can see the difference here. Of course, I had to print weather one more time in this case. Let me reduce a lot of unwanted new lines in here. Let me print weather. Maybe I'll print weather here. print weather here like this, and keep this way. You can see that the last print statement, which prints weather, you can see it actually shows up the state Karnataka, which got added in here. So if you want to modify the value for an existing key in a dictionary, or if you want to add a new key value pair into a dictionary, you can always use dictionary of key equals value. The key exists, the value is replaced. The key does not exist, a new key value pair is added like you see here. Now, if at all I want to remove a key value pair in a dictionary, how do I do that? Well, there are two ways. Actually, there are multiple ways, but I'll talk about two ways at this moment. But there are some more ways to empty dictionaries and all that. So, now this cell, let me do it right here. Maybe I can just do it right here. Let's say I want to remove raining. I want to remove that key value pair called raining. So I want to just do that. I can just say del weather of, specify the key. If you recall, I talked about the del statement when I talked about a list. I told you that you can use del to delete an item from a list based on its index. It also worked with a slice. If you just recall on lists, I would have told you about that. Pretty much the same way, I can remove a key value pair from a dictionary if I know the key by using del weather of whatever key I want to remove. So once I do this, and if I try to print weather, you can see that raining is now removed. You can see raining is equal to false. Raining mapped to false was there. That got removed from this dictionary. But of course, del is a statement. So obviously, once you remove it, I cannot get that by using it like an expression. I told you that you cannot use del in a right-hand side expression because del is a statement keyword. Right? Statements are not expressions. I hope you remember that. Now, if at all I want to remove a key value pair from a dictionary, I want to store it somewhere. I want to say access it through some other means. I want to just pick it up from a dictionary. I want to refer it through some other variable. So if you want to do something like that, there are two ways to do it. Let's try this now. Let's say this time I want to remove state. I added state. I want to remove it. So I can just do this. I can just say s is equal to weather dot pop of state. The pop method for a dictionary, you must pass an argument. You can't just say pop as is. For a set, you say set.pop, it just removes an item. You can't decide or determine which one. So one of the item is removed. That's what happens when you call pop. But for a dictionary, you have to say pop of which key value pair needs to be removed. Just like you say del weather of raining, but maybe if you want to use pop instead, you could say weather.pop of raining. But here, raining is already removed, so I can only pop out maybe the last item, which is state. So I can just say yes is equal to weather.pop of state. So when I use this like an expression, the return value would be the value of the given key. So if I try to print, this time I'm going to use format literal strings. So I'm just using f string. I'll just type what is being popped out is represented as s, and I'm just going to use weather is equal to show what the dictionary is at this moment. You can see that what got popped out, the value for the key is what is returned when you pop. And now the dictionary has that key value pair being removed. You can see that state Karnataka is removed from this dictionary. So this is how you can perform some basic operations. The last pop or variant I should talk about is something called pop item. Maybe I have a dictionary of a lot of key value pairs. I just want to keep removing key value pairs from a dictionary one at a time, right? I don't really care which one. I just want to remove it. I can do that by using key comma value is equal to weather dot pop item. Pop item returns a tuple of key and value. I'm unpacking the tuple in k comma v. Unpacking, right? When I use the comma separated variables in the left hand side. So when I try to print it now, I'm just going to copy the same thing which is there here. And this time I'm going to use the variable names that I want to print are key and the value followed by the dictionary. Now, because I call pop item, I did not really specify which one. So it just removes whichever key value pair is easy for it. Looks like it always goes from the beginning. So it looks like city Bengaluru will be gone now from the dictionary. That's not city Bengaluru. I think it removed the last one. It goes from the last. It removed humidity colon 78 pop, just like the list you pop from the last, right? It works the same way. This is pop item. Pop item will remove a key value pair from a dictionary. It is somewhat predictable if you're using modern dictionaries in Python. It always goes from the last to the beginning. The last item that you added, that will all be removed. So you can actually sort of treat a dictionary like a stack with key value pairs. It might work. It does work. Assuming that you use, you know, dictionary of key is equal to value to add new key value pairs in a dictionary, and to remove those key value pairs, use pop item. Think of pop item as the exact opposite of this operation that adds a new key value pair. So you can use some interesting idioms here. For example, let's say I have weather, which is, I'll just take this weather here. This is a common use case pattern sometimes where you might have a dictionary of key value pairs. You want to take out each item from a dictionary. That means each key value pair, you want to remove it from a dictionary until the dictionary becomes empty and you want to process them. So you can do something like that. So you could, I'll just print weather here. This is what it is. I can write a nice Pythonic idiom here where I can say while weather. Don't want to say while weather. What does it mean? Weather is a dictionary. A dictionary is a collection. When you use a collection in place of a Boolean expression, that's what while expects, right? A Boolean expression. What does it mean? While the weather is not empty. That's how you read it as. So you read this as while the weather dictionary is not empty. While it has some items. While it has some items. I want to keep removing them. How do I do that? I can say key, comma value is equal to weather.pop item. And then I can say print. I'll use the format string this time again. Popped is equal to value is equal to dictionary weather is equal to. I'm just going to print very detailed information here. So I think I'll just use it as weather is equal to, so we'll save some screen space perhaps. If I go far to the right, so I want to avoid that. Ultimately, I'm just going to print what weather is at the end. Run this now. You can see initially the weather dictionary has got all these elements which I constructed. And that's what you see here when I printed weather. While weather, key comma value is equal to weather.pop item. And then I'm printing this message. What got popped out? Maybe the last key value pair. It looks like raining false. Key is raining, value is false. Now the weather dictionary does not have the last item that's this raining false is popped out. Another iteration, you can see that humidity value is 78 and that is now no longer there. And then it pops out temperature and it's a value, it's a list. Value is a list in this case. And you can see weather only remains with just one key value pair. Last pop item invocation will make this dictionary empty by popping out the last key value pair that remained in the dictionary. And after that, now because the dictionary is empty, this while loop will evaluate to false because it's an empty dictionary. Empty collections evaluate to false in Boolean context. And now I'm printing weather, which will show up as an empty dictionary here. This is one kind of an idiom that could be used in certain use cases when you're dealing with a huge data set and you want to keep retrieving items, removing them while you process till the end of the dictionary. So you could use this idiom. So I told you how to add a key value pair. how to modify a value, how to change a value, or replace a value for an existing key, how to remove elements from a dictionary. Once you know the key, you can remove the key value pair by using the del construct or del statement, rather. Or you can also use a pop method to remove the key value pair while returning the value that's being removed. You can also use pop item to just remove arbitrarily a key value pair from a dictionary where you don't say exactly which key. Any key value pair could be removed, right? So these are some of the methods you should know. And the next thing is, how do you access items of a dictionary? How do you access them? Well, as I told you, let's go back to this weather here. Accessing is pretty straightforward. We use the subscript operator, right? So if I try to print, okay, if I try to print weather of city, this is how you can access a value for a given key. But I also told you about using the get method in case you want to return a default value or none if the key does not exist, rather than raising an expression, raising an exception. So I told you that non-existence of a key with the subscript operator raises an exception, right? But using get method, instead of raising an exception, you can expect it to return some default that you determine, or maybe none when you don't pass a second argument. We saw the get method, but I'm just going to repeat it all over again just to make sure that the concepts are well imprinted for you. So there's nothing wrong in it. So you can use get of city like this. Even when you say get of city and maybe not found, the second argument is ignored at this moment because city is already found. But in case you look for a key that is non-existent, then second argument is returned by the get method. These are ways you can retrieve values from a dictionary if you know the key. But then there are also some more methods I should talk about, which is weather.keys will return just a view to the key of a dictionary. This is a little interesting. These are newly introduced forms or types, I would say. Made its way in Python 3, but it's also backported in Python 2.7 if you happen to use it. They are available in a different name though. I think it's called view keys. Yeah, by the way, if you used Python 2.7 especially, you have confusingly redundant methods inside in Python 2.7. The dictionary.keys would return a list. If for all you want to just iterate of the keys and you don't want a list, you want just an iterable, then you use dictionary.iter keys rather. And then you have something called view keys if you want to do a view. What exactly is a view? Think about it this way. When I say dictionary.keys, you can see only the keys being printed here, right? Only keys are listed. Views are like collections. They work pretty much like collections. So if you just take this here, k is equal to weather.keys. I'll try to print k, and I'll also print type of k. It'll just tell you it's a type called dictionary keys type. I can just do this. I can just say maybe print check for an item in this key. Let's say city in k. That will work. You could also find out the length of it by using len of k. That would work. And you can also iterate over it by using for I can just say x in k, print x and is equal to space. This pretty much passes all the tests for a collection. But the view is not really a full-blown collection. As the name suggests, it's a view to an existing collection. It's a customized view to an existing collection, which is a dictionary. A dictionary's got key value pairs. But by creating a dictionary keys view, you're only seeing a window of only the keys of a dictionary and not the values. So you're only interested in the keys of a dictionary. You can use dictionary.keys and treat it like a normal collection. The only limitation is that this is not mutable, so you cannot really add items or remove items from here and all that. It's a view. You can only read it, right? This is also called as a key view. This is just a memory optimized, memory optimization technique. When you're dealing with an extremely large dictionaries, let's say you're dealing with dictionaries with millions of key value pairs. It's very common when you work on slightly larger frameworks written in Python. So having a huge dictionary with a lot of millions of key value pairs is pretty common. Such cases, for certain algorithms, you don't want to see the entire dictionary. You want to see only the keys or only the values, or sometimes you want to see both keys and values in a read-only manner. And that's exactly what views give you. The views are, in a way, sort of related to, not related to, they share a lot of similarities in terms of the design of database views. If you have worked on relational databases, especially I remember very well about the SQL compliant RDBMSs, Oracle or MariaDB or MySQL or PostgreSQL, all of these variations, you can actually create a view to a table. So you have a table with multiple columns. But for certain querying, you don't want the entire full blown table to work with, but you want to just get a small partial part of the table, maybe with just few columns in it. Maybe you have a table with about 20, 30 columns. Maybe totally a denormalized table, let's say, with 20, 30 columns. But from there, I'm just interested in the 4 columns to do certain analytics. I can create a view, which is like a view window of that table with only about 2 or 3 columns, and I can work with that as if it's another table. It's mostly used for performing analytics and not performing any updates inside them. Right? You don't do insert and update kind of queries. You only run select queries within that view. So it's more convenient to manage things. So the same way, dictionary views exist. So when you say dictionary.keys, you get the view to the keys. And as you might have guessed, you can also try dictionary.values. That's basically weather.values in here. And you get a values view to the values. If you want to access the keys and values together in a common view, you can also say weather.items. What are the common use cases of these views is for iteration algorithms. For example, if at all I try to use a for loop on a dictionary, it lets me iterate only over the keys, right? So you get, but if you have seen me using the for loop on a dictionary, where was it? Not here. This while loop. Or maybe I'll just type it and show it to you. Anyways, it doesn't matter. So let's recreate the dictionary so it looks more complete. I just print weather here. You can see that weather is printed. Now I want to iterate over this dictionary. So if you want to iterate over it, if you just try to use a for loop as is, let's say for maybe v in weather. And if I just write print v and end is equal to space, what do you see happening? It only iterates over the keys. But some of you might say, oh, I know the key, so I can get the value by using weather of v this time. I mean, using the variable name as v looks very wrong to me. So I'm going to just call it as k to indicate key, the shortcut. For k in weather, and I can just say k here. If you really want the value from this, you can actually say weather of k in this case. This is what you need to do, right? You say weather of k. Maybe what I can do is I can make a format string here, which can make it more intuitive. And I can use an indirection like this. And just maybe use weather of k equals. I forgot to close the quotes here. Close this. Oh, did I say weather of k is equal to? All right. Oh yeah, that's right. Yeah. Maybe instead of telling k is equal to, let's just use like this. Let's say k is equal to weather of k. I think that will make sense. It'll make it more concise. You can see that. Maybe we can add a end is equal to comma here. Or maybe, yeah, that's right. The for loop iterates over key values. It only iterates over keys. Once you got the access to key, I'm printing the key here, and I can say dictionary of key, which will print the value. Next iteration, again, you can see temperature. The value for temperature is weather of k. We'll return this. This is k. This is weather of k. Again, k. This is weather of k. In a loop, right? And you can see it's print. I've added a comma space at the end. That's how the comma space is separating each of those elements. It also ends with a comma space at the end, by the way, right? So you can see once you know the key, you can always access the value. But sometimes you just want to iterate over the values. You're not really interested in the keys. You don't want the key. You just want the value. Then what you can do is you can somewhat make it a little more optimal just by using for v in weather dot values, because all the views are iterables. They seem to look like collections. They are like fake collections, proxy collections. To understand about proxy collections, let me give you a real world example. There were times when you walked into a store and bought stuff. Even today, we do that sometimes. We walk into different stores and we really pick up stuff and put it in our cart and we buy them. These are like real collections of a lot of items. Let's take an example of a more specialized store, like a bookstore or a book library, or maybe a bookstore where you can go and buy books. Now, I can give you my business card. I can hand over my business card to you. And I can tell you that I own a bookstore or maybe a book library with about several thousand books. You ask me what you want, and I'll get a book for you. You look at my business card that I hand over to you. You look at my face and you say, okay, I'll trust you. And one fine day, you will look at my business card and find out my contact number, and you call me up and say, I need this book. Reality, I don't own a bookstore. What I would do instead, maybe I go and buy that book on your behalf, add my profits. Maybe I know a deal. I got a deal from some wholesaler, and he would give me a book for a lower price. So I'll add my cost, and I'll say it to you. But to you, I own a bookstore. Reality, I get a book from somewhere, and I give it to you when you ask for it. That's exactly what these views are doing. These views are like a proxy. They implement a proxy pattern. So when you're trying to access items in here, they are getting the items from elsewhere on demand and handing over to you when you trade over them. That's how they work. So they are sort of memory efficient, right? They give you only a view to a value, but you sort of don't have to worry about the keys. So it gives you that kind of convenience, right? So when you run this, let's say for, I don't have to print anything else. I'll just, okay, I'll just print V. That's sufficient. That's enough. You can see that. This is how we can iterate over the values of a dictionary. Now, a very common nearby question people ask me is this. Once you know the key, you can always find out the value. But I have a dictionary. When I know the value, I want to know which key is it. Well, if you have a use case like that, you should rethink on the design. You always look at a dictionary, you organize a dictionary such that you want to look up the values based on the keys and never the other way around. If you want to do it the other way around, it's anyway going to be a very complicated way to do it. You have to traverse the entire dictionary and verify you have to go through every values and check what key is binding to. It's complicated. The point is, in the real world, I don't see this happening these days, but there was a time when we had this yellow pages. I think it's the telephone directory. Days when we had landline phones before the mobile technology took over, and we have address books and all these things, right? And on the phone right now, smartphone era. But I still remember my childhood days when we used to have a landline phone, maybe about 20 years back. 20 years back. We still have a landline phone, and we used to have a telephone directory alongside with it. So if you want to call up some place or call up somebody, we look up in the telephone directory. The telephone directory is organized in a particular manner. The telephone directory is organized in a way that we have the name of the person, name of various establishments or shops or even industries, all the different addresses. It's all organized based on that in the alphabetical order. So you walk through the alphabetical order like you look into a dictionary, and you look for a particular shop or a particular place, anything as such, and you look up the establishment and you look for that name, and then you look up the telephone number and you call up. So here, the shop name is a key, or the person's name is a key. Once you know the person's name, you can find out the number. If I give you that telephone directory and I give you a phone number and I ask you to find out the person name, That's not going to be easy. All right? Because the telephone directory is organized based on the keys, which are names of people, and the values are the telephone numbers, not the other way around. So if I give you a telephone number and ask, find out the person whose number is this. Oh, if it's a big, thick telephone directory with about several lakh or maybe a million numbers, good luck. You're going to be spending days and months searching for it. But if I had a telephone directory which is the reverse variant of it, where I have another telephone directory where I have all the telephone numbers as keys and the values are the person's names. Maybe the governments have them. Maybe the police department have them. That's useful for them. Investigation agencies will have them. It's very useful for them. You want to find out an anonymous scholar and you want to know, his number or her number, and you want to find out who the person is. You want that directory. So it's all about structuring your dictionary based on how you want to access it. Right? It's not like, so if you think that, sometimes I know the key, I want the value. Sometimes I know the value, I want to get the key. The worst scenario, you need to have two dictionaries. One where the value is key and the key is value. You can do that. But there are limitations. As you know, as long as the values are hashable, it's okay. You can always transform them as keys. Otherwise, it's not going to work. Someone might ask me, how do I switch the keys and values? Right? Let's take a simple dictionary for this. Before I talk about that, I'll finish also the items and then I will tell you about that problem statement. It's better, right? So if you look at the keys and values, you realized how you can access the keys or only the values and iterate over them. And that's where these methods are useful. Sometimes you want to access both keys and values. You want to iterate over them. Then instead of using for k in weather dot keys and keys, you can directly say for k comma v in weather dot items rather, and then you can just print k comma v. This time I'm just going to leave it with new lines. This is weather dictionary which is being printed, but you can see that I'm able to iterate over the keys and values here. So if you want to iterate over key values in a dictionary, you can actually use this idiom for key comma value in dictionary.items colon, and you can perform anything there where you want to process the keys and values. I also had to go back and retract back and tell you a bad practice. I've seen very commonly a lot of Python code. People put weather dot keys. Don't do that. It's not going to give you any benefit. When you say weather.keys, what happens is it creates a dictionary keys view. That's an object. And through that view, you're going to access the key. There's just a roundabout way of accessing the key of a dictionary, but you don't have to do that. You can directly say, if you want to iterate over the keys of a dictionary, just simply say for key in dictionary. If you see any Python code where they put for key in dictionary dot keys, open close parenthesis, and you do something in the for loop, on that for loop, remove the dot keys. You don't need it. It'll just work fine without it. It'll just save a little bit of memory and maybe a very few microsecond of performance, perhaps, avoiding that act of creating another view. Because when you actually use for k in weather, it returns a dictionary key iterator. But when you say weather.keys, it returns a dictionary keys view. Dictionary keys view is called dict_keys. But again, on the dictionary key view, when the for loop is going to iterate over it, it's going to ask for the iterator. The dictionary keys view will return a dictionary key iterator. So the dictionary keys view, which was created in the midst, was really unnecessary. So you don't have to explicitly mention that. Just say for key in dictionary. That's it. If you want to iterate over the keys of a dictionary. If you want to iterate over values or items, then you might need to explicitly mention what you need. You need a value view, only then you can get the value iterator. When you get the items view, only then you can get the item iterator. To get the keys iterator, you can just use the dictionary as is in your for loop. You don't have to explicitly mention that as dot keys, right? So these are some of the methods you should know which are mostly, I would say, the dictionary iteration helpers in a way. If you iterate over a dictionary, three ways to iterate: over the keys, or the values, or both keys and values together. So all these three works. When you use this dictionary item iterator, you can get it back into list, for example. So let's try this. I have a dictionary here. It's called weather. If you now just say uh, maybe W is equal to list of weather. It could be list or it could be a tuple of weather. And when I print W, what do you think would happen? Can I create a list from a dictionary? Think. Or can I create a tuple from a dictionary? Well, some of you might think, oh, it's confusing. If I try to create a list from a dictionary, what do you think is going to happen? Some of you might think it's just going to automatically give you key value pairs in a nicely organized manner in a list or a tuple, but sorry to tell you, that won't work. But does it throw an error? No, it does not throw an error. Or what you would get instead is this. When you look at this expression, just think what happens when you pass an argument to a list constructor. What do you think is going to happen? I told you that list constructor and tuple constructor would take any iterable as an argument. A dictionary is an iterable. So when you use a for loop to iterate over a dictionary as is, what do you get? You only get the keys. So what you'll end up getting when you use list of weather is only the keys. A list of keys. But what if you want list of values? You can actually do this. You could actually try. I just say print W here. If you want to get the list of values from a dictionary, as you know, you can actually use this list of weather.values. This is how we can create a list of values from a dictionary. Or if you want to, let's say, get both keys and values together, you could use print list of weather.items. Remember, use a list constructor. Technically, you can use even a tuple constructor. Will work just fine. You can also use set constructor as long as the items you're dealing with are hashable, not just iterable, hashable, right? So all the items must be hashable. That's something you should care about. You can actually create a set of weather. It's going to work because keys are obviously hashable in a dictionary. You can always create a set out of it. But then if you try to create set of weather.values, it can fail. In this case, it will definitely fail because one of the values is a list, which is not hashable. Even items is not going to work because the second tuple that you see here is not hashable because it's got a list inside it. Right? Something you should know about. If you're going to create a set, creating a tuple, creating a list, no problem. It's going to work. Right? So these are things you should know about various forms of performing operations on a dictionary. So if at all I have an existing dictionary, let's call this weather again. There's one dictionary called weather. Let's say I have another dictionary here. Let's say, info is equal to another dictionary where I'm just going to use something like, say, wind speed is equal to 40. I don't know what that number is. Doesn't matter. And I could also use something like, say, sunny is equal to true. And maybe I could also use something like, say, what are the components of weather? I don't know. Maybe pressure. Atmospheric pressure, let's assume, is equal to, I don't know what kind of unit you would have. So I'm just going to put some random number here. Don't make any sense of this. As I told you, I'm not a weatherman. So this is another dictionary. So I have weather is one dictionary and info happens to be another dictionary which I just created. I want to update all the items of info into weather. How do I do that? It's pretty obvious. You say weather.update of info. This will do the trick. Now if we print weather, all the key value pair, all the key values of info is integrated into weather. It's updated into weather. So weather is now big with all the elements of info added in. Of course, if info has any keys which seem to be duplicates of what is already there in weather, then info's keys, key value pair, will replace weather's key value pair. Like maybe info had this time, maybe I'll use city is equal to, right? I'll use city is equal to, and I'll use Mumbai, for example, another popular city in India. Find it in Maharashtra. So, when I try to say um, info is equal to dict of wind speed, sunny, pressure, city is equal to Mumbai, you see that the city is equal to Mumbai is going to clash with city is equal to Chennai that's already there in weather. So if you say weather or update of info, when you print weather now, you can see that city has now changed to Mumbai in weather. It's going to update it. The word update means all the existing keys would be updated with the new key value pairs for the dictionary. So that's what update method does, right? So this is how we can access keys and values and items. You can also update a dictionary, or sometimes you want to make a copy of a dictionary. How do you make a duplicate copy of a dictionary? Any guess? I think I already told you. All the mutable collections have two methods which are common amongst them. What are they? Dot copy, dot clear. List.copy, list.clear. You know what that does? List.copy makes a duplicate copy of a list, a shallow copy, by the way. List.clear will empty a list. We also saw that for a set. If you just remember the previous session, I told you set.copy makes a replica of a set. Set.clear will empty a set. Pretty much the same way. If you want to make a duplicate copy of a dictionary, you can just say maybe, new weather is equal to weather.copy. And now you try printing ID of weather and weather followed by ID of new weather. And new weather. And you can see the output. Well, you can see that the IDs are different. The reason why they're different is because obviously they're two different objects, isn't it? So you can see that this creates a complete replica of the dictionary. Oh, when I say complete replica, remember it's a shallow copy. It is a shallow copy. After you create this replica, if you go and update some elements in here, this time I want to show you something interesting. Let's say I showed you how to change a value for a dictionary by using dictionary of key is equal to value, isn't it? So I showed a dictionary of, let's try this. After I made this copy, if I try this, if I just type weather of city equals, let's change it to another city. I'll call it Pune, which is another city in Maharashtra in India. So if I now print weather and new weather, let me add some lines, a small border line or a barrier around this so you can see it more clearly. It's into 50 here. Yes, hyphen into 50 puts this line, right? This entire line that you see here. And you can see that when I change the value for city in weather, for weather, city is Pune, but for new weather, city is Mumbai. That's fine because it's a copy, right? But there's something called temperature here. I'm going to update the ingredients of temperature. Just watch happens. Watch what happens. I'm going to now try weather of temperature. Remember, weather of temperature, the value is a list. It is a list. And the list is mutable, so I can update it. So I can just say the 0th item of that list. I'm going to make a number which is very, let's make it 18, for example. Let's say 18.45 or 43, some number. Currently the number is 24.21 and just change to 18.43 here, right? So I'm updating this specific item here. So I selected the temperature as a key from a dictionary whose value is a list, and from the list, I'm trying to access the 0th index, which happens to be the first item here. And that's what I'm changing because it's in the left hand side. So when I do that, and if I try to gain print weather and new weather, put a hyphen to separate it, and another boundary, and print this. I changed the temperature in weather, which is one dictionary, but because these two dictionaries, weather and new weather, are going to be sharing the same list, because I updated the list, it's linked into the other dictionary. And how do you make an exact full-blown replica of this dictionary such that I could have a complete backup of the dictionary? So I modified the original dictionary deep down. It doesn't update the current dictionary. How do you do that? Any guess? Remember? Well, if you remember, when I talked about a list and talked about nested lists, and I told you the problem with shallow copy, and I told you about the opposite of shallow copy is deep copy. So if at all I make a deep copy of this, how do you do a deep copy? You need to import a module. It can say from copy, import deep copy. This time is always, almost always, you import it like this, right? You would never say import copy and use copy.deep copy. Never do that. It's easy to just represent deep copy because it's the only place where you'll find this function. It's rare to find any module that has a function by name deep copy. If you find such a module, blame the author, right? For choosing a wrong name. So here it is. So you say from copy, import deep copy. And now this time, I'm just going to repeat this whole thing here. But before I do that, I want to say this time, new weather 2 is equal to deep copy of weather. Okay, I don't want to confuse you people too much of things in here. What I'll do is, let me just copy this cell completely so it makes sense, because I want to show you the exact difference. So say new weather is equal to deep copy of weather. And to keep it more self-complete, in the cell, I'm going to say from copy, import deep copy. Remember, deep copy is a function. So it works with all Python objects. You can use it for a dictionary, for a list, for a set, for any arbitrary Python objects. You can make a complete deep copy of it by safely using the deep copy function from copy module. So here I'm repeating the same thing, but this time I'm using deep copy here, so it looks more cleaner. You can see that. Okay. I think the temperature is okay. I think the weather's temperature. Let's do one thing. Okay, I'll change the weather's temperature to something else here this time. I'll change to something else. I'll just change it to, let's say I'll make it 16.42. Initially, the temperature for both of them are sort of identical, but whatever changes I made here in weather is not update new weather, because new weather is another copy of a dictionary, but it's not just a shallow copy. Even the inner list is duplicated. So therefore, whatever changes I make in weather is not updated in here. And that's it. So you can see how you can make a copy of a dictionary by using dictionary.copy. But remember, that's a shallow copy. If you want to make a deep copy, remember to use deep copy function from the copy module to make a deep copy of a dictionary, which will make a complete nested recursive copy of the entire nested dictionary, let's say. If at all you want to empty a dictionary completely, you can also do that. It's pretty straightforward. You can use dictionary.clear. So I'm just going to empty new weather this time. So if you just print new weather, and now I'm just going to use new weather dot clear and print new weather one more time. You can see the dictionary becomes completely empty. This is how you drain out all the elements of a dictionary. just like how you do it for a list or for a set. It works pretty much the same. It does not create a new dictionary, by the way. It's emptying an existing dictionary, clearing an empty existing dictionary. So these are some of the methods I told you in a dictionary. So let me summarize what methods I talked about. Uh, Sorry, let me make this a markdown. Dictionary methods. So what are the methods I told you? One of them is the dot get method. And then I talked about dot keys, dot values, and dot items. And then I talked about dot pop and dot pop item. And then I talked about dot update, dot copy, and dot clear. How many methods did I cover? Like 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 more methods. I guess there are 11 methods even in a dictionary. Just like there are 11 methods in a list, I counted 11 methods in a dictionary. What are those 3 methods? Well, do I have time? Okay, I think we are out of time. Actually, it's almost an hour. So I will be covering the 3 methods. These are fairly advanced methods. One of them is rarely used. There's a method called from keys, which is rarely used. I'll talk about that though, what it does. Couldn't find real world use cases as much. Very, very rare to use that. I'll talk about these 3 interesting methods. The methods I'm supposed to talk about is dictionary.setDefault, and there is a dictionary.fromKeys. And what's the other one? Have I missed another one? No, I think, yeah, 2 methods. I need to cover 2 methods, not 3. Okay, because I forgot to count it here. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9. 11 methods, 2 more methods, right? So it's dictionary.fromKeys and dictionary.setDefault. I'll just put those methods in here, but in the next session, I'll talk about those 2 methods of a dictionary. Or maybe I can cover it now. So it's fine. I think I have another 10-15 minutes. I can just cover that. So I'll say set default, right? Dictionary.setDefault. I'm going to add it here. And I'll also add dictionary.fromKeys. I think it's better not add in this level. I want to add it at the end. It's a very rarely used method. From keys. Set default is a fairly confusing method, to be honest, because you won't get it the first time. For most people, that is. Oh, sorry. I don't know why this happens like this. Okay. This is a markdown, isn't it? Maybe the indentation is too far. That's why. Yeah. I told you about how to access a value based on the key of a dictionary if the key exists using the get method, or return a default value if the key does not exist. Set default is merely an extension of a get method. It works like a get method at the surface, but it also alters the dictionary if needed. I'm going to tell you how it does. Let me take a very simple dictionary. Okay, let's take weather itself. It's fairly simple enough. Let me take the, I'll just copy this one. This is a literal notation anyways. So I'm going to copy that here. Weather is equal to, let me add this. Now, when I type print weather dot get of key, or I'll put a default value, which is let's say not found. Okay, and let's call this key is equal to city for now. And after that, I'm just going to print weather one more time to show you what the actual dictionary contains after this. No difference. The weather was, the dictionary is not altered by any means. When I say dictionary.get of key, because the key is found, city is there in the dictionary, it got the existing value and no changes. Even when I look for a key that is not found, it's just going to return not found. It does not alter the dictionary, right? That's what get does. Get just gets. if it's there. Otherwise, it's just going to return the second argument, which is the default. Now, the same cell, I'm going to make a copy of it. I'm going to replace the get with set default. And now observe what happens. First, let me assume the key is city. The key is city. Set default will record two arguments. You have to pass two arguments, the key and the default value. The key that you're looking for and the default value. These are the two arguments that you need to pass to the set default method for a dictionary. Now, when you run this, you can see that if the key is found, right? The key is found here. The city is found here. It just returns the value just like the get method, just like how the get method did. When I pass the key as city, if I pass key as city for the get method, it looks exactly identical. Look at the output. You can see it prints weather.get of key not found, it returns Chennai. Even here, weather.set default of key not found, it returns Chennai, and no changes to the dictionary whatsoever. Both cases, right? But there's a difference the moment the key does not exist. That's the use case for set default. So if all the key does not exist with the get method, it just returns the second argument which you pass here, which is the default value to be returned, like not found. That's what is returned. The dictionary is not altered. But what the set default does is, if the key is found, it returns the existing value for the key. But if the key is not found, apart from returning the second value which you pass, second argument that you pass to set default, which is the default value, it also updates the dictionary with that key value pair. So if I try to type like say state, this is an example. This time, it returns not found just like it did for get method. No difference. But the state not found is also added into a dictionary. So if you want to, let's say, conditionally update a dictionary, you have a dictionary of key value pairs already there, but you want to conditionally update a dictionary. Like if the key is not existent, you want to add a new key with the value that you set. But if the key is already there, don't change the dictionary. Return the existing value for it. For such use cases, use set default. There are a lot of interesting examples which I will cover in the next session. The next session I'll give you more interesting examples where set default will be used. And there is also another simpler variant of a dictionary called dictionary. It's a simple variant of a dictionary in the collections module. It's actually called default dictionary. It's a more think of a simplified implementation of a dictionary which implements set default by default. Okay, it's there in the collections module. Some people find using set default complicated. When you look at that, it doesn't look very obvious, right? Whether a set default of key not found, it returns a not found, but the dictionary is updated. You may not know that. Default dictionary makes it more explicit. It's more obvious when you try to use it. So that's the difference. But I'll cover that much later. But I'll give you some examples of dictionary of set default in the next session. The last one I should talk about is from keys. From keys is a very unintuitive method, in my opinion, because it's not meant to update the current dictionary. It's quite strange. The way you use from keys is like this. It's not meant to be used in the current dictionary. Not at all. Because from keys returns a new dictionary from keys that you pass as an argument. Strange. So I'll tell you what it is. If I just say weather.from keys like this, it may not look very obvious and what it is all about. It just throws an error. It says from keys expects at least one argument but got zero. Now, what is the argument it takes? Let's find out. We just say open parenthesis here. It says it requires an iterable. From keys requires an iterable. So when I say iterable, it can be a list or a tuple. So I'm just going to give a list of some things. Let's say A, B, and C. Now what does it do? It returns a new dictionary. It does not do any updation of the current dictionary. It does not change anything in weather. Weather just is remaining as it is. No changes to weather whatsoever. The way you use from keys is mostly like this. Let's say I want to create a dictionary where I just want to create a template dictionary which only has the keys, but I have not determined the values as yet. I want to just leave it as none or some default value, right? So let's say I have something like statistics dictionary, which I'm creating, a stats dictionary, stats. I want to create a dictionary which has got keys like, say, CPU usage, memory usage, and number of processes. Initially, I want to keep all the statistics to zero. The values I want to keep it to zero, and later on, maybe I want to update it. So I want to create that kind of a skeleton dictionary. Then this is how we do it. The right way to use from keys is create an empty dictionary like this. Dict, open close parenthesis, creates an empty dictionary. But on that empty dictionary, which is returned in this expression, you say dot from keys of, decide what all keys you want. Maybe I can just say maybe CPU usage, mem usage, and then maybe nprocs to indicate number of processes. I pass this as one of the argument. When I do it like this and print stats, this is what you get. But maybe I want the default value for this not to be none, but I want it to be numeric. Maybe I want to start with 0. So I can pass another parameter here, 0. It's useful to create template skeleton dictionary with values being pre-initialized to all nulls or nuns or zeros, right? Nuns or zeros. So it's meant for that. But the way you use it is a little counterintuitive. You say create an empty dictionary, dict dot from keys of iterable, comma default value, and then that creates a new dictionary. That's how you use it. This is what from keys does. It's a little counterintuitive, but that's how it is. I don't know if I use it. I never found a use for this. Creating a skeleton empty dictionary. I don't know, maybe. But if you do find some use for it, let me know. I couldn't. I never found this being used anywhere in most of the projects I've seen. But maybe you found a use for it. If you have been dabbling with Python for a while, if you know where this is used, do let me know. Maybe you can post it in comments so I'll know better. So this is what from keys does do, right? Maybe you want to create some skeleton structure where you can update the values later on. You can do that. Maybe the value can be anything. The value can be 0, can be an empty list, can be another empty dictionary, can be anything at all. So that will be preset to all the values for these keys. All the keys will have the same value initially, and then you can update them. Maybe you can increment the CPU usage, decrement the memory usage, and all that. So it gives you this benefit. So this pretty much sums up all the methods that you should know on a dictionary. So the get method, set default, keys, values, items, pop item, update, copy, clear from keys. You count it. It's like how many? Like you have 3, 6, 7, 8, 9, 10, 11 methods. 11 methods for a list, 11 methods for a dictionary. Set is the only collection that has slightly more methods. I think a lot of the methods are redundant. We saw that. Union, intersection, update, intersection update, difference update, and symmetric difference update, is superset, is subset. All these methods are redundant. You can use the operators instead. The only methods that you'll need to worry about in a set for most cases would be add, remove, discard, and pop. And maybe update. Add, remove, discard, pop. Maybe update, but you can also use pipe equal to if you want to for that. So the number of methods in set is actually lesser. Most of them are redundant operator methods, right? So there will be 5 methods there. But you can see a dictionary, 11 methods. List, 11 methods. Tuple, 2 methods. So by this, we come to the conclusion of the series where I talked about all the built-in data types that you should know about in Python with this session. So by now, I think I talked about numbers, I talked about strings, I talked about tuple, I talked about list, I talked about set, and I talked about dictionary. Even when I talk about strings, I think I talked about bytes and byte array especially, and this pretty much concludes it. The next session will introduce you to functions. I think I'll first cover functions because you need to know functions. Once you finish I think you'll have 2 sessions on functions perhaps. So once I finish 2 sessions on functions, you'll have a very thoroughbred understanding on how functions work. One of the sessions will focus on the function prototypes and features, and the second next for the forthcoming session, I'll talk about interesting things you can do with functions. Hopefully, I will finish in 2 sessions, or maybe it can spill to 3. We will see based on how I go. I'm trying to make it as slow as possible. And once I finish functions, we will do a lot of interesting things with the concepts we learned. We'll do some interesting exercises with it. More exercises I will give you at that time. Right now, I'm not giving you any exercises. I plan to give it to you maybe after I finish functions. So then things are more completed. So you can try out interesting challenges that I'll give you. And after which we look into modules and packaging and file IO and stuff like that. We will take a couple of more sessions. I think I foresee another hopefully 10 sessions. Let's see. So I hope you are finding this video interesting. I hope you're finding this entire series interesting. If you do find it interesting, as usual, do hit the like button, and that's how I know it. And do post on comments. And if you have any queries, just post them on comments, and do subscribe. And I will see you on the next one. Thank you.